Okay, so this is the first in a series of tutorial videos about the C# programming language. I've just installed a vanilla version of Visual Studio 2019, and I'm just going to go straight into a new project and we'll get started, and I'll talk about the things as we go through them. So when you do this, you should be able to see console applications here. I've just distilled it down from all languages to C# because that's what I'm focusing on for this. If you don't see the console application there, you may need to add other dependencies to this project into the software, Visual Studio. But it should appear there. If you have any problems, please contact me directly and we'll sort it out. Alright, so I'm not going to worry about the install process because I've already done it. So I'm just going to short label my console applications, CA1 underscore, and then give the name of the application I'm doing. So this is the generic Hello World application. Alright, this is the first common base application that they all do, and I think it's a great place to start. Oh, right, I've already got one called that. Well, I'm going to tweak the name here and put a double underscore. Don't do that, just have it as a single, because I've already created this application once in testing and you get the idea. So while this creates everything that we're going to be doing, so the reason I'm doing console applications is I want to keep the programming as simple as possible so you can see what's going on. So it makes what I think of as the code is very pure, as in you're not worrying about graphical stuff or any of the other things that may exist in your application. So here I'm going to focus in on basically what does all this code mean initially, and then we're going to go through and modify it a little bit. So starting on line 1 at the very top, we have using system. Excuse me. Using is basically just a keyword. It tells us that the program is going to use a library. In this case, it's called the system library. The system library has multiple components, and as we go through and build up more and more complicated programs, we'll use a couple of extra bits and pieces of them. We have a namespace. The namespace is generally where your program will exist, and so namespaces can be used to build up more complicated libraries that you can then use, but for what we're doing here, I'm not going to worry about it. Finally, we have the class of program, which is basically just a wrapper. So these two layers here are a wrapper that names what program we're writing. This is just telling us that it is a program, and the critical part is actually wrapped in here, which I've just highlighted from lines 7 through to 10. The first part is the static void main, and then something in the square, the curved brackets. The square brackets are also important. I'll talk about that in a sec. So static means that it's not going to change. Some programs, I think, static's just a keyword that's always sat there for me. I assume it's static, and we'll go on from that. Void is another one, which is basically, in this case, it's the return value. So if you have a program that does something special and it has to pass back a piece of information, this is where it would sit, and it can pass back one piece of information. In this case, void means it's passing back nothing. Main basically means it is the main program of what we're creating, and everything we're doing starts here. Then we have a string, and I'll get to that when I talk about variables in the second tutorial, which is our list of arguments, and the square brackets means that there's an array of them, but we'll get to that down the track. So everything outside of this above here you don't have to change, everything here and below you don't have to change either. The critical part is in here. So our first program is basically just a simple hello world, and if I don't even need to hit the 2 enters I've just added in, but if I just go run it, it will take a few seconds to assemble the code, basically compile it into machine code that Windows can understand and that we can then actually use, or it will run in this case. This always takes a few seconds, especially once you get this stuff started. So here we have our program, and we drop into debug mode, which is why the background screen changed, and it goes hello world, and then it goes, oh yeah, we ran something, and we exit and press any key to continue. So if I press any key, it's done. All right. So here, what I'd normally do with my group, because there's one or two changes between 2017 and the 2019 version I'm now using of Visual Studio, is that it does some things at the end to let you wait and see what's going on. Normally that screen would just instantly vanish with the previous version, and we'd have to add in something to make it slow down. But before we get to doing that little extra, we want this hello world, we want to add to it. So I'm just going to add a console dot write. I'm going to write in some text. Actually, we'll keep it nice and easy. We'll do a right line. There is actually a difference between the two. And what you'll notice is I've put in two regular brackets and a double quote mark. And inside the double quote marks, I can add a string of text, or basically something typed. This is me. And every statement or a line of code should end with a semicolon. Unless, this is where things get a little tricky, it ends with a curly brace. So a curly brace gives you a block of code. So all of that is part of this here. And it'll make more sense as the more we move into it, but just we'll work with this for the time being. So if I do another console, in this case I'm just going to do a write. I'm going to give it a piece of text to write with, and go, this is, and I'll leave that as it is because I want to show the difference between the console and, sorry, the write and the write line. So write, and this time open the brackets, close the brackets, and me with a few extra little flourishes. And then I'm just going to do a console.readline. Yep. Open bracket, close bracket. Oops. Semicolon. Alright. So I've got no little squiggly little red lines to say I've done something wrong. So just quickly, while this is compiling, each write line statement will write a line of code and end it and go down to the next line. Each write statement will just write the text and then stop. So right where that cursor is, it just stops just before the me, before adding the me onto the end. And then the readline statement waits on the end here, and it's actually waiting for me to press enter there before resetting to end the program. So if I run that again, now is it F5 or F10? I can't remember. I'll just hit the button. So it runs, second time I run it, it actually runs a lot quicker. I can actually type in a whole bunch of stuff here. It doesn't go anywhere, it's never used, but I can type in stuff because I've done the readline statement. So the readline statement takes no information, but what it's doing is it's listening to the keyboard, and every time you hit something on the keyboard, it, records this whole long string and then passes it back to something else to be used. But we'll do that in the next program. So at this stage, I've built my program, it's all written, I need to save it. Now, there's a couple of ways to do this, but I can save the program as a .cs file, which is a C# file. And if I hit save, it will hopefully save it as is, or I can save all. This saves all the components of a more complicated program. So that saves everything. What you'll notice here on this side is I have my Solution Explorer. I have two files, the dependencies, which is the Microsoft.NET Core Framework. This allows, and there's a whole list in there, I don't need to talk about all that, but this framework allows us to write software that should, I'm not going to say will guaranteed run, should run on all Microsoft platforms. I think it can be translated across to the Mac OS operating system, and can also run on Linux. Now, that's with a giant caveat, which is where programmers earn their money, of making it work with these different systems, but it should do. Should, in giant inverted commas, just take it as that. The next is the program.cs. This is the text file that you can see here. So our Solution Explorer gives us an outline of the parts of our program, and as projects get bigger, if we incorporate graphics or other bits and pieces, then we have like a whole solution in here that we can then basically work with. And if I should be able to right click on this and go copy full path. Yes, I'll copy the full path, and I'll open up a little one of these, paste in that full path, delete the end of it, and hit enter. This is my full solution. It's actually stored in a sources repo thing under my username. And if we look in here, what we can see is we have, we have our solution. This is what you double click on to open this up to actually then modify the whole set. And when you've completed a particular task, you can see there's a couple of repetitions here because I've done this a few times. If I right click on this, I can then zip it using 7-zip into a .zip, or I can actually send to compressed folder, and you can actually submit that as part of the work you're showing me. But this is the .sln file, or this solution file, which will be at the top of this directory structure. will give you the program that you need to then modify. If we go dive in a little deeper, we have objects and binaries. So this is my CS code, which is this thing you can see here. That's the project file, which has all the parts of the solution. And then we have objects, which is all those dependencies, all the things that needs to work properly. We also have a debug version, which I'm not going to worry about all that detail. But we have the bin version. These are your binaries. So this is the debug binary that it's created. And I have this program here. So if I double click on this program here, we have this. This is my working program. And we are done. So I've saved the program. I've shown you how to access the CA file, or sorry, the executable. And that's pretty much it.